There's a molecule shaped exactly like a soccer ball, made of 60 carbon atoms. And the first place we ever found one in space was right here, inside this glowing ring. This is TC1, a planetary nebula about 6,500 light-years away, and it's not actually a planet. The name is just old astronomical slang for anything that looked round through early telescopes. What you're really seeing is a dead star's last breath. A star roughly like our sun ran out of fuel, puffed up into a red giant, then shed its outer layers into space over thousands of years. What's left at the center is a tiny hot white dwarf, and all that shed gas is still expanding outward in these nested shells. The James Webb Space Telescope captured this image, and the detail it pulled out is something else entirely. Look at the upper portion of the outer shell. See those concentric ripples in the red gas, like rings spreading from a stone dropped in water. Those shells mark different episodes when the dying star shed material at different speeds. But here's the part that surprised researchers. Threaded through that orange shell is something called buckminsterfullerene, C60, 60 carbon atoms locked together in a perfect soccer ball shape. In 2010, this nebula became the first place in space where anyone confirmed those molecules exist. They're not spread randomly through the nebula. Webb's data show they sit in a thin spherical shell, right at the bright inner edge of that orange glow. The geometry of it is almost too tidy to believe. Now, look at the very center. There's a bright yellow-white point right at the heart of that pink inner sphere. That's the white dwarf, a city-sized ember about 100,000 degrees. And just above it, if you look carefully, there's a faint, curved shape that researchers describe as an upside-down question mark. Nobody is sure what made it. It could be a knot of gas twisted by the star's magnetic field, or the shadow of something denser caught in the outflow. The fact that it looks like a question mark is honestly too perfect. TC1 has been studied since the 1960s, and it still hasn't given up all its answers. And over on the right side, the gas isn't smooth at all. It's shredded into bright streamers, almost like the shell is tearing apart unevenly. That asymmetry is real. Something about the environment, or the star's own history, pushed more material out in this direction. The same turbulence that makes it look like fire is probably what helped cook those carbon molecules into buckyballs in the first place. Shock fronts, uneven densities, chemistry happening in conditions we can't replicate in any lab on Earth. A star dies, and as it goes, it accidentally builds one of the most elegant molecules in chemistry, a perfect carbon sphere, 60 atoms, no leftovers. We named the molecule after an architect because it looks like his domes. And the star had no idea. It was just running out of fuel. We'll be here tomorrow with whatever the selector pulls next. Subscribe so you don't have to remember to come back.